Welcome everyone to our 10:30 virtual career series event focusing on engineering, and this particular event is hosted by Nikon Precision Europe, and we're joined by a number of the team there who are going to have a discussion with you this morning about their opportunities for graduates and a general insight into the company and the type of work that you can get involved in there. Like all of our series, we are encouraging you to be as interactive as possible, so do pop any comments or questions you have into the chat and questions function, and we will deal with them maybe throughout the presentation, most definitely at the end. We're delighted to be joined again this year by Carl Shine, who joined us last year to share those events. Carl is our technical recruiter from Nikon Precision. We're also joined then by Gordon Chase, who is a site coordinator, and Amy O'Reilly, who is a field service engineer. So lots of good stuff to learn about this morning. And I'm going to hand you over now to Carl, who's going to start off the conversation. Thanks, Carl.
Great, thank you very much, Catherine. So yes, everybody, well, some of you may have seen me before last year's event. As Catherine said, I'm the technical recruiter for Nikon Precision, so I would be sort of the first point of contact if and when you apply. As Catherine said, I have two colleagues here, Gordon and Amy, both of whom work on site at our main customer's campus. They are going to tell you a little bit more about what they do and what we do. So the basic introduction is we're going to talk about Nikon Precision Europe, what we do, why we're hiring, the type of roles that we're hiring for, the training program, that's very interesting. We'll be speaking a little bit about that. And then obviously what we can offer you and how you should apply if you're interested. As Catherine said, if you do have any questions, you can stick them in the chat box. We will leave time at the end of the presentation for the questions. In practice, I think we'll probably cover a lot of the usual questions during the course of the presentation. But as I said, if you stick them in there, if we haven't covered it, we'll deal with them at the end of the presentation. And if you'd like a longer discussion, then we can arrange a time. You could send me your CVs or whatever, and we can arrange a time for a later date for a longer chat. So we'll start with the history of Nikon. Normally I would ask Gordon and Amy to introduce themselves, but Catherine and I have both stolen their thunder there. So I'll move straight on, and Gordon and Amy can jump in then at a later stage. So just to give you a basic background on us, on Nikon. So Nikon Corporation was established initially in 1917. We are one of the world's leading optical companies. So most people know us for cameras. Obviously, that's the consumer electronics. There's a lot of marketing goes in there. But there are a number of different divisions, a number of different applications for the optics that we make. So imaging is the camera division. We also make measuring equipment, metrology. We make medical equipment, and we make precision equipment, which is us. And this is the semiconductor arm. So we make tools which other companies, the likes of AMD, Intel, Texas Instruments, Seagate, Samsung, they would use our tools in the manufacturing process, manufacturing semiconductors. So in 1980, Nikon developed the world's first production-worthy step and repeat photolithography tool. That sort of rolls off the tongue. Gordon will tell you a little bit more about photolithography in a minute. But since then, since 1980, we have developed 60 different models of semiconductor lithography systems. And we've actually printed over half of all the integrated circuits ever made. So there's every chance that the device that you're watching the webinar on at the moment contains chips which were manufactured in Ireland using one of our tools. So I'll hand over to Gordon. Maybe, Gordon, you can give us a little bit more insight into the technical end of things.
Yep, thanks, Carl. So as Carl mentioned, we create machines that print computer chips. These machines basically take the chip design that the customer requires and transfers that design onto a silicon wafer. Now, the level of accuracy that this requires is down at the nanometer level. And so we must ensure that the machines are running at peak performance at all times so that the customers get the smallest, fastest, most energy efficient and reliable devices possible. I think the following graphics may help to, if I can share the screen here, may help to illustrate some of the aspects of what we do. Hopefully this comes up. So we work in a clean room in a high volume manufacturing environment. Our machines use a process known as photolithography, which is the process of optically reducing the required image or photo mask, as in the picture, and transferring multiple prints of this onto the wafer. We use laser light to print the image onto the surface of the silicon. And as new chips are designed and developed, our machines also evolve to enable our customers to print at finer and finer resolutions. So one of Nikon's key strengths is our optics. And in our machines, we have lenses to ensure the exposure light is at the correct size, position, and shape for the product required. The type of laser light we use is based on the customer's product specifications. Lenses such as the main projection lens, as you can see in the diagram, are at the heart of the machine. These are industrial lenses. They're not quite like what you'd find in a camera. They're about 2 meters tall and 1 meter wide and weigh around 1,500 kilograms. The machine has many different components, and there's a wide variety of disciplines working in it, such as mechanical, electrical, pneumatics, lasers, and optics, as well as the software that runs the entire system. So one of the breakthroughs in recent times in technology that we work with is called immersion. And this was a major change in the semiconductor industry. This involves filling the space under the projection lens with water, and it's another step to enable us to achieve greater resolution and so print even smaller features within the integrated circuit. With immersion, obviously, came new challenges. We need to ensure that we manage the water and all the defects that interact with it. So hopefully that helps to understand a bit about what we do. At Nikon, we provide service to our customers during the full life cycle of the machine, whether it's during installation, wait for production ramp up, or in the sustaining production environment. Our team provide expert analysis and solutions to enable optimal operation of the equipment 24 hours a day, 7 days a week. Overall, the production environment is very advanced with customer-driven targets, so our jobs are both very challenging and highly rewarding. Because of the complexity of equipment, we require people with very strong technical and troubleshooting capabilities who are able to follow strict procedures and have the ability to take on complex tasks and understand how all the components work together in the machines. So Carl's now going to tell us about some of the roles we have available.
Great, thanks, Gordon. So I just want to go back a little bit and just explain that we're Nikon Precision Europe, which is distinct from Nikon Precision Inc. Incorporated, which is in the US. We are based in Germany, and we have branches. We cover Germany, France, UK, Israel, and Ireland. Though we're currently focusing on hiring for Ireland. We are a very international company, though, and we work very closely with our colleagues around Europe, in the US, and in Japan, obviously, as well, where the parent company is. So during the pandemic, semiconductors had been designated as an essential industry. So we've been working right through the pandemic, although like many other industries, there have been some changes to our work and training patterns. So for example, all the admin and support staff work from home. So I've been in this room for a year and a half or so. And our engineers, who absolutely have to be on site for the physical hands-on work, follow very strict social distancing guidelines. Now, some of the training is also being conducted remotely. We'll talk about that a little bit more later. Intel, who are one of our key customers, as you are probably aware, well, they have 3 high-volume manufacturing plants globally. One is in the US, one is in Israel, one is Ireland. So we cover 2 of the big 3 for Intel. You're probably aware that they are building a new fabrication plant at the moment in Leixlip. I know it's been on the news a lot recently. They're putting that's going to cost about $8 billion, so it's a massive ramp up. And for us, it will be as well. We are one of their key vendors, and we expect to be installing a number of our tools at the new manufacturing environment. So the new fab is still under construction. I believe construction is almost complete. They're now moved on to the kitting out phase. So we're still not ready to go, but our training takes 12 months to complete. So we have to hire people in advance to get them ready through the 12-month training so that they're ready to go when the new plant comes online. So we've hired a number of engineers, a high number of engineers last year. We've hired more this year, and we will continue to hire next year and on into the future as the plant ramps up. So all of the research, design, development, manufacturing of our tools all happens in Japan. So outside of Japan, we basically focus on sustaining support and sales. So we have a number of different engineering roles based around that. So for example, a service engineer, which Amy will tell you more about in a minute. We have engineer in charge, which is more of a coordination / leadership role. So service engineers can, let's say, escalate an issue to an engineer in charge. And we have technical support center engineers who are essentially the second line of support. And they would also interact a lot with the engineering department in Japan. Then we have hardware engineers who would perform the more, let's say, intensive or invasive hardware work on the tools. And then we also have teams of data analyst engineers who support either the service or the applications engineers. So there are a number of different roles, and as Gordon mentioned, there's a lot of different disciplines involved. So we do hire people from electronics backgrounds, electrical engineering, mechanical engineering, electromechanical, mechatronics. We also hire a lot of physicists, people with backgrounds in optics and lasers. So we hire, from a wide variety of disciplines, but everybody's essentially working on the same tool, because they are very complex machines. Industry experience, obviously, in any of these fields or in semiconductor industry is a benefit. Actually, Gordon, do you want to?
Yeah, sure. We should know, I suppose, that the work we do often requires engineers to work a variety of different shift patterns. It depends on the role people are selected for. There may be a requirement to work a standard day shift pattern like Monday to Friday, 8 to 5. That pattern is also standard during the training periods and when we're upskilling people or some people gain exposure to some of the other roles as they progress through the training. We also have engineers supporting the customer on what we call compressed workweek shift patterns, which consist of 12-hour shifts, 7 in the morning to 7 in the evening, or 7 in the evening to 7 in the morning. And this alternates between 3 days on, 4 days off, or 4 days on with 3 days off. So the required pattern that people work is entirely dependent on the customer's requirement. So while employees are given a work schedule, we need people who are willing to be flexible to work to a variety of different shifts. The good news is that we do have an unsociable hours allowance where engineers are well recompensed for working outside the normal hours. So Carl mentioned some of the training earlier. Our engineers, whether experienced or recent graduates, must complete a training program up to 12 months before being able to work alone on a machine. The training is broken up into different stages. There's about 8 weeks currently of classroom theory and technical training, which is primarily based in our off-site training centre. Although due to the ongoing impacts of the pandemic, some of this training may be held online. Topics in the training include optics, sensors, mechanical operation of the machine, the software functions and data analysis that's associated with it. The technical training is followed by local on-the-job training and mentoring with an on-site engineer, as well as abroad where we can identify training opportunities. So where and when engineers undertake each stage of the training varies depending on the availability of our training sites and tools. We do provide as much advance notice as possible. However, we might require at times for people to travel at short notice. On-site training will initially be Monday to Friday, as I said, and then later move to shift hours. All training and any travel required, of course, are fully paid for by Nikon. As you can imagine, COVID had a big impact on our training in the last year and a half or so, due to the restrictions in terms of travel and face-to-face interactions. However, we did work through the pandemic and have successfully onboarded and trained a high number of new engineers in that period, both recent graduates and experienced people. So Amy, who joined us last year, is going to talk through some of her experiences of joining us during the pandemic.
Hi guys, so my name is Amy and I joined the company about a year ago as a service engineer. I applied for the job through LinkedIn, which was really quick, really easy to do, so I would recommend it to all of you who are interested. I had a pretty seamless onboarding process for the company. Obviously, we're dealing with highly precise, complex machinery, so there is a lot of training and information to absorb in the beginning months. So if, like me, you don't have much of an engineering background or if you don't have much of a physics background, it's all covered in the training, and the training starts from the basics, like the really basics from the ground up, so you will be fine. As a new hire during COVID, our training was mostly done online or in the remote training office in Maynooth, focusing on the theory that's behind the machines. Recently, there's been a full machine built in the Maynooth training offices fit with power, air, vacuum lines, so it is much easier to understand all the training that you're doing, being able to see the real life mock-up. It's extremely helpful for practicing like your day-to-day procedures, ones that you're going to have to do all the time in the fab, but in a much more relaxing environment where you don't have to worry about smashing a €1,000,000 piece of glass with your elbow. There's lots of interactive training sessions, like a cabling course where you learn how to correctly, neatly attach cables, which is actually more interesting than it sounds. And there are many opportunities to travel to different countries to work on different tools. The lads all went off to Scotland there during their initial training to work on a mock-up tool and get some hands-on experience. on some of the tools that we would have in the fab. Obviously, because of COVID, many of the training travel opportunities had to be put on hold, but it is starting back up now. A lot of the lads have headed over to US in the last few weeks, and Israel, and I myself am hoping to jet off in the new year, fingers crossed, just to get a more diverse training experience, get hands on lots of different tools. So as Gordon was saying, a lot of the work we do is in the customer fab. You're working directly on the tools, you're troubleshooting, you're fixing all the issues that arise. Obviously, at the beginning, you might be able to troubleshoot because you won't have as much experience. But my advice is just to be like a sponge, absorb all the information that's thrown at you. And it does, I promise, start to come together. And before you know it, you will really be able to contribute to the team. When you start, you're assigned a mentor, and it's their job to guide you through your first months. They answer any questions you have, and you also have this team of all the lads on your shift who are so knowledgeable. They know everything, it seems, and they're so friendly, and they're more than happy to help you in any way they can. There's also a great social aspect to the shift. In pre-COVID times, the whole shift would eat breakfast together, lunches together, organize trips away for some team building. And even during the pandemic, there was virtual events, like we had origami workshop, pizza parties, burger parties, and stuff like that. And now that the restrictions are starting to be lifted, we are seeing the return of some work nights out, which is great for getting to know your coworkers better. I myself had lots of issues with the software aspect of the job, could not get the hang of it. So you find the techie guy on your shift, and they help me organize my laptop more efficiently, get all my notes together, which just makes life 1,000 times easier. So that's it for me. If you guys have any questions, please ask. I was in your shoes about a year ago, and I had a million questions. Thanks very much for listening, and I hope to see some of you in the future. So, Carl, I think you're now going to speak about how to apply.
Yes, absolutely. Thanks very much, Amy. That was great. Hopefully it will help people, calm their nerves, I suppose, about the initial onboarding process, because it is, I think a lot of people are worried about it, especially with COVID. So it's good to know that we can still, move forward with the training and onboarding, although it is a little bit more difficult to get to know people over Teams. Great. Okay. So yeah, as Amy said, well, I suppose I can tell you first of all what we offer, and then I'll tell you how to apply. So we are, as you all know, we are a Japanese company. So we do have a lot of Japanese cultural characteristics, let's say. For example, in Japan, it's not uncommon for employers to spend their whole career or a long time, let's say, with one employer. In Europe, that doesn't tend to happen as often. As it happens with us, with Nikon Precision Europe, it has been common before, obviously, the recent hiring phase that we've been going through. It has been common for engineers to stay with us for a very long time. We've many engineers with us for 20 years or longer. That's, I think, as much to do with the advanced technology that we have, that you're getting hands-on. You're getting hands-on with technology that you're just not going to see outside of the sort of the clean room environment in Intel or other companies like that. But we also do have an excellent benefits package, which I'm sure goes a long way to help as well. So we do offer a competitive salary, and I know that's an annoying thing to hear as a candidate. Competitive obviously depends on your qualifications and experience. But the benefits package I can give you more information about, because that's sort of standard across the board. So we do have a car allowance. Now, I suppose I should say there is an initial probation period. Probationary period traditionally has been 6 months, which is kind of standard. We've had to extend that during COVID to 9 months because, as Gordon and Amy have explained, a lot of the training has been done remotely rather than hands-on, face-to-face. So typically you would, when you start, you'd be assigned a mentor, and they would work with you on a daily basis. And that way we can get constant feedback as to people's progress. When people are sitting at home learning online, we haven't been able to get that sort of feedback. So we did extend probation to 9 months, but we will push that back to 6 months as soon as we get everybody back in face to face. So during the probationary period, you would get your basic salary, you get a car allowance and 24 days holiday. The car allowance is a bit of a misnomer in that if you were living down the road and you were cycling to work, you would still get the car allowance. So it's not dependent on receipts or anything like that. It's a flat allowance that everybody gets. And that's quite high. We also, once you pass the probationary period, then you can elect to keep the car allowance, or you can apply for a company car. So they're leased, we cover tax, insurance, and there's a monthly allowance for fuel. That's your decision then. Although just bear in mind that you would pay benefit in kind on the company car, whereas the car allowance is taxed as income. Then we also get the contributory pension scheme, where the company pays 7% of your salary towards your pension. We get fully paid private healthcare insurance with Leia that would cover the individual, spouse and children. We have a discretionary annual performance-related bonus. So it depends on things like the company financial performance, but also the individual performance. So we set goals with our managers, which we revisit throughout the year to make sure that we're keeping up with them. And then depending on how well we achieve those, that would affect our share of the available bonus. And then obviously, as Gordon and Amy have already explained, we do have the comprehensive training program, which lasts a year roughly, and involves international travel, which, well, all expenses are paid there by us. We also have a lot of opportunities for professional development. Career development is very important to us here at Nikon. We spend a long time finding great engineers, and then we spend a long time training great engineers. And then, the longer people stay, the more they can add value. So we don't want people to feel in 2 or 3 years that they're not growing, they're no longer challenged, and they're going to have to leave to find, the next step. We want to provide that in-house. And that feeds into why we have such great retention as well. So there are definite steps for advancement within the team. Although from what I've heard from a lot of the engineers, they are very challenging roles, and I've been told many times that you never fix the same problem twice. That it's always something new every day you come in. So you will be challenged, let's say, as an engineer. So finally, then, how to apply. So what we've done today, we've told you about us, who we are, what we do, what our future plans are in terms of hiring, the kind of roles we're hiring for, and then what we offer you. If you're interested in applying, there are a number of ways. I will put our email address into the chat box here. That's NPE for Nikon Precision Europe -Ireland-HR at nikon.com. So it's a long one. I'll type it in so you can find it. You can also find us on LinkedIn. If you are searching for us on LinkedIn, be sure to put the Europe in, because there's Nikon Precision Europe and there's Nikon Precision Inc. So if you put the wrong, you might end up with a job in America, which maybe you want. But if you want to work here in Ireland, look for Nikon Precision Europe. Or as I said, you can just email a CV to us directly. And so that is it from us, Catherine.
Thanks very much. You just caught me as I was copying the LinkedIn URL to put it into the chat there. So thanks for that, Carl. And you can put in the more complicated email address there. Really grateful for your participation this morning. It's helped decode a little bit the highly technical roles that you have there. But I'm sure what it has also done is really whetted the appetite of our engineering students who are logging in live, or those who will again watch this online or on demand after the live event, just to go back and maybe look at the pieces, particularly maybe around what Gordon has taken us through. And Amy, thank you so much for your honest and uplifting contribution around your past year. And it's been difficult for all graduates who have been onboarding during this time, but particularly in a role which requires such technical training. So you've given us a really good insight and a real sense of positivity that it is very much a possible thing to do, but also how excited you are about the role and the company. So thank you for that. With that in mind, I suppose some questions are coming through as well as some of my own, but some practical questions there, probably, Carl, for you. Just typically how long the application process takes. So we know that now that we can email you or that we can follow you on LinkedIn, which is how Amy got her position. But also to think about how long that might take and when people should start thinking about applying, seeing as mostly who we'll have here today are final year students.
Yeah, that's an excellent question. We are hiring at the moment. So if somebody were available now, we can offer positions this year. We are also planning ahead, though, because as I said, it does take a long time to get people through the training. So we have to we have to know what our headcount plan is for next year. So we will have roles available next year. What we've done in the past is these events, given the time of year for final year students, as you said, is a sort of an introduction. Yeah. And then early next year, let's say February, March of next year, there may be more events. And we would certainly start contacting people by then at the latest. If we were looking to hire 2022 graduates, I'd like to be speaking to them in February or March.
Okay.
because obviously a lot of other employers are going to want to speak to great engineers as well. But also it gives us a chance to get to know each other. We can discuss the roles in great detail. I will always give each candidate 30 to 45 minutes phone call to go through everything in detail to make sure that they know what they're applying for, and that we figure out which role will be best suited. They will be best suited for. Then obviously we arrange the interviews. Now we have been doing the interviews online because of COVID. So they would look something like this. We're using Microsoft Teams. There'll be a couple of different stages. There will be the standard, say, HR section where we go over the CV, qualifications, experience, interest in the company, knowledge of the company and role, so do your research. And then we would pass you over for the technical interview. Gordon does a lot of those interviews as well. So typically we would ask people to prepare a technical presentation. So a project that they've worked on, some problem solving or troubleshooting, or some engineering project that they've worked on that they're particularly proud of, let's say, and they're willing to talk about in depth. And then there would be a more technical interview where we would cover their knowledge of mechanics and electronics and troubleshooting. Coding, data analysis are also very useful for pretty much all of our roles, given the movement in technology these days. You don't just swap parts out anymore. You have to really investigate everything before you actually do any invasive work. So data analysis and software. So it's quite a wide-ranging interview. It takes about 2 hours. But I will, as I said, have a long conversation with everybody before we get to that stage, so they'll know exactly what to expect. So there's a very long-winded answer to your question, Liam. It takes as long as it takes. It depends on when the individual is available. But we have roles available now, and we will have roles available next year.
Yeah. Okay, thanks for that, Carl. And I think it's really good to have that sense of what is ahead of you, and good to know that there is a certain element of you being that guide through that process, Carl, when that initial conversation happens. And then Gordon, technical wise, I'm sure some people may alert them, and maybe that might lead on to yourself, Amy, in terms of somebody who's recently gone through that process. There has been a question connected to what Liam has asked, but in that wider sense as well, is there anything in particular from the application process point of view that you would like to share from a tip or guidance point of view to help you manage that interview better, and that you think would be useful to share?
Definitely, you know more than you think you do.
Okay.
There's you're hit with a lot of techie stuff, and you're going, oh my God, I have not got a clue. But then when you actually break it down, you use more of your basic information, the basic things you learned in first, second year of college. It all just starts coming together and you start understanding more. And as I said, everyone in the company, they want to help you. They want to see you succeed. So they're not going to try and trip you up. They're not going to try and make you look stupid. They're going to try and help you. Sort of, if you're not sure at all, say you're not sure, and they'll help you through that.
Yeah, great. Really good advice there, Gordon. Seeing as you're somebody who's leading out and assessing these applications, anything from your perspective you think would be useful to share?
Yeah, I think the thing you said, particularly say in the interview process, we may get into some of the technical aspects of what we do and ask questions, but it's really going back to the basics of engineering and trying to get people to think through problems, see how well they can understand what we're talking through. We might talk through in the interview, for example, some of the high level operation of the machine that somebody will never seen before, but we're looking for somebody who can kind of absorb that and maybe ask some intelligent questions about what they're seeing and show that they're able to understand what we're talking through.
So thought process is that idea of that sort of approach to thinking and approach to problem solving is really important. And I think that's important for anybody tuning in as well, to listen to that in terms of not necessarily having the answer, but the thought process that goes into it seems to be of really importance in terms of showing your capacity in that area. And as we have very strong engineering graduates here in DKIT, I'm sure that will be no problem to them. We, I suppose, we're coming up to the end of our session. As I say, it was really useful to find out about hiring now for any graduates who are actually tuning in, who are already completed their studies, that applications are open now, and to use that email address or follow on LinkedIn. And then again, to start looking around that February time for the next intake. So but thanks also, to each of you. Yes,
sorry, Catherine, just to add to that, if somebody's interested in having a chat now, by all means, send in your CV or send me a mail and we can have a chat now. Even if you're thinking about next year, there's no reason why we can't make contact at this stage.
Really good. Okay. Thanks very much for that, Carl, Gordon, and Amy. Pleasure having you here this morning, and thanks for sharing so much useful and insightful information.
Thanks, Catherine.
Thanks.
Thank you.
Take care, everyone.
Thank
Bye.
you. Thanks, Catherine.
Thanks.
Thanks, everybody. Bye now.